Dr. Tom Van Flandern, Ph.D. in astronomy from Yale University. He spent 20 years at the U.S. Naval Observatory. He's the editor of the Meta Research Bulletin, and during the past several years, he's been a research associate at the University of Maryland Physics. Tom organizes the Eclipse Edge expeditions that take you to the best viewing sites for solar eclipse as well. And here he is on Coast to Coast this hour. Hey, Tom, how are you? Welcome back.
Oh, thanks, George. Pleasure to be with you again this evening.
I love this story about Mars, that something hit it, something that I think you and Richard have somewhat talked about, but you've got different views on this. But this particular one here, according to their calculations, they say whatever hit Mars was big. What do you think?
Well, they've got a conjecture that it's big because it wiped out an entire hemisphere of the planet. The trouble is they just can't quite make it work when they do computer simulations, and it violates a lot of the observational evidence. I mean, there was no question a big cataclysm that affected Mars because it's like two separate hemispheres glued together. One half of Mars is saturated with craters, and the other half is smooth and flat. So you have to account for the difference somehow. But we don't think they have the details right yet. In fact, we think it's kind of the opposite of the track that they're presently on.
Did I read this correctly today, Tom, where they thought possibly this object could be about 1,000 miles long when it hit the planet? Now, that seems awfully large to call simply an asteroid.
Yes, you're exactly right about that. Their conjecture is that this happened very early in the solar system when, according to their theory, there were a lot of large objects running around. They had another one hitting the Earth and knocking off the Earth's moon. These are interesting theories, but we know a lot now that rules out these theories. Anyone who knows a little dynamics knows that they just can't be made to work in celestial mechanics. So the new version of the 20-year-old theory today suggests, again, a huge object coming in to hit Mars and knocking off almost a complete hemisphere of the planet to account for the smooth hemisphere with the absence of craters. But I don't know if you can imagine an impact that leaves a planet, half of a planet, flat and smooth, as opposed to one that leaves a big hole in it.
Right. Exactly. Steve Squires, one of those who advanced this ancient impact idea, and of course, he's the lead scientist for the twin Mars rovers that continue to function. If you and Richard C. Hoagland, and you share similar views, had a chance to be in a meeting with Steve Squires and he would have presented this ancient impact theory, what would you have said to him, Tom?
Well, I'd point out the long list of evidence that doesn't agree with that idea and direct him to the alternative hypothesis that does account for all of the available evidence on Mars. In their theory, they've got to say the damaged hemisphere was the smooth one. And that the cratered hemisphere was normal. They base that on the fact that the moon and lots of other bodies in the solar system are cratered all over, so that looks normal to them. And they actually use crater counts as a way to estimate ages, so that's why they can claim that this all happened 4 billion years ago. But there's another alternative, and one that we proposed almost 2 decades ago ourselves. And that's based on not just the evidence that the Mars has these two separate hemispheres, one cratered and one smooth, but all this other evidence, too, that comes into the picture. One crust, the cratered hemisphere is much thicker than the smooth hemisphere. Much of the atmosphere of the planet was lost. There was a shift in the pole location. By 90 degrees, the spin axis basically tipped over. And it has xenon-129 isotopes, which are indicators of a gigantic explosion. That doesn't occur in nature. And on. We have a list of over 24 lines of evidence in our website and technical papers. And amazingly enough, there is a coherent theory that accounts for all this. Should I briefly outline?
Oh, absolutely. But you both agree that Mars had some kind of explosion. The question is, what caused it?
Yes. That's precisely it. So instead of the northern hemisphere being the damaged one, we have the southern hemisphere being the damaged one. And we think that's because there is a strong line of evidence from what's called the fission theory for the origin of the solar system that indicates that Mars is not the original planet that occupied that orbit. There was a gas giant planet originally there. In the original counting system, we thought it was the fifth planet out, so we called it Roman numeral V for 5.
And was Mars a moon to this planet?
That's exactly right. It had 2 moons, Mars and the one we now call Bellona.
Okay.
And apparently exploded as astronomically and geologically recently as 65 million years ago. Long time ago for us, but
not in celestial clocks.
That's right. That's a heck of a lot younger than 4 billion years, which they're talking about. The interesting thing that happened here at that time was the death of the dinosaurs and 70% of all species on Earth, and a huge episode of volcanism and changes in the atmosphere and oceans. Well, that apparently is a side effect of the Earth being damage to the Earth from this big explosion of planet V.
And would we have been hit by some of the debris from this gaseous-type planet?
Exactly so. We would have, and there are already 15 known large impact craters from that epoch, and the number keeps going up. Year after year, we keep finding more. I'm talking about on Earth now. And we're perhaps 50 to 100 million miles distant from the explosion when it occurred. You can imagine how damaging that would have been to moons of the planet, which are right there in the face of the explosion. But the interesting thing about an explosion is because when the explosion happens, it's just going to blast one side of the moon, and the back side, of course, is protected from the impacts. And that's just what we see with Mars. One side blasted, the other side protected. Now,
what about the asteroid belt? Are those asteroids there, or the remnants of something? Might it be from this gaseous-type planet that blew up?
Yes, with a caveat. In the new thinking, planets occur in twin pairs, and there actually were 2 planets that formed the main asteroid belt. This planet V that I just mentioned in the present orbit of Mars, and one that's nicknamed Planet K a little bit further out in the middle of the main asteroid belt that probably exploded about 250 million years ago. So those were responsible for the asteroid belt, the Planet K giving us the carbonaceous type asteroids, very dark and very much larger on average. And then the explosion of Planet V closer in gave us the inner main asteroid belt, which is more silicaceous or glassy.
If Mars was one of 2 moons, what happened to the other moon?
The 2 moons were, with their parent planet gone, continued to orbit each other as they continued to orbit the sun. And that situation lasted another 62 million years, and then 3 million years ago, 3.2 million years ago, according to the astronomical evidence, Bellona, which was getting closer and closer to Mars because of tidal forces between the 2 moons, finally reached a critical point, and it exploded. And that produced a second blast onto the surface of Mars, but not too different in location from the first one, because Mars and Bellona would have been keeping the same faces toward one another, and the face that was heavier with the thicker crust would have been the one facing Bellona when it exploded. So the result is that moon is gone, and 3.2 million years ago, although that was a much smaller body exploding, we also see traces of things happening here on Earth. That's another geological boundary, and it was the change in Earth climate globally from a fairly tropical period to the onset of ice ages that have been occurring ever since.
That's fascinating. Now, Tom, the two moons of Mars now, Deimos, Phobos, where did they come from, or were they always in the area?
They, too, are captured asteroids, and there have been lots of theories flown over the years as to how they got captured, because it's very difficult to do that with the dynamics. You need kind of two impulses to get something captured. You can't do it just with a close approach or something. Anything that comes from outside winds up going back out. The explosion theory does it in a very neat way. There's going to be some large fragments from the explosion that go zipping past Mars, grazing right through its atmosphere as they go past. And because they go through the atmosphere, they slow down and they can drop into temporary orbits around Mars. Now, those guys are going to continue to dip through the atmosphere, and they'll burn up pretty soon. But while they're there, the bigger debris that comes along from behind, it's going to smack into some of these fragments orbiting Mars, and that smack can drop a bigger piece into a permanent orbit because it's well above the atmosphere of Mars when that happens. And indeed, pictures of Phobos have shown that it has this huge impact crater at one end.
When we're going to keep you for phone calls, Tom, when we come back, and I also want to talk about the possibility of life on Mars. This happened so many billions of years ago, according to these scientists, 60-some million years ago, according to you and Richard C. If your theory's correct, life could have been established on Mars, correct?
That's certainly true, yes. There's plenty of time for that, and these cataclysms probably were instrumental in affecting the evolution of life there, just as the corresponding events happening here on Earth affected life here, killing off the dinosaurs, allowing the ascension of mammals.
What causes these planets to blow up?
There are three theories of planet explosions. The short idea is that as planets evolve and cool, the cores can reach what's called a critical point. The critical point is like the temperature at which, temperature and pressure at which water will turn to ice, or another critical point on the high side, water would turn to steam. So you have what's this change of character or phase. If that happens in the core of a planet as it's progressively cooling, then you'll have a sudden change in volume, which can result in the planet either imploding or exploding.
This is fascinating, Tom. It's also somewhat scary. I hope it doesn't happen to good old planet Earth.
Well, we always knew that Earth wasn't immortal, but astronomers were, up to now, had been assuring us that it was good for another 20 billion years or so, or maybe at least 10 or 15 until the sun exploded. Now that we know about planet explosions, we might only be good for a few 100 million years, but that's certainly nothing we or our grandchildren need worry about. And by that time, either the human race will be extinct or we'll have populated the whole solar system and beyond.
Let's talk about the possibility of life on Mars and your phone calls with Tom Van Flandern next on Coast to Coast AM. And we're with Dr. Tom Van Flandern. We're going to take your phone calls. We're getting his reaction to a study that came out that the possibility of an ancient impact may have explained the mystery of Mars, that its hemispheres are different. Tom doesn't agree. We'll talk with him about the possibilities of life on Mars, past and present, and then we'll take your phone calls right here on Coast to Coast AM. Phoenix landers up there on Mars, Tom, scraping for samples. They are pretty sure that they scraped ice. What about the possibilities of past or present life there, and how extensive? What do you think?
Well, the truth is that the Viking landers way back in 1976 had life detection experiments on board, 3 of them, and they all came back registering positive for life. But that was discounted quickly by, shall we say, the interests of the times on the grounds that there were no organic molecules. Well, since then, Gilbert Levin has shown that the instrument wasn't sensitive enough to detect organic molecules. It couldn't even detect them in an Earth sample with a known organism in it. And in the meantime, he was able to tighten up the experimental results and show that it really was a life detection experiment. The disappointing thing about Phoenix, for those of us who know what's going on here, is that a generation ago, we sent life detection experiments to Mars. But Phoenix is conspicuously absent in any kind of life detection experiment. They didn't want to risk that happening again, because if they were to look in that soil sample for anything more than water, which is the goal of the mission to find out if there was water there, if they look for anything more than that, that would undercut the justification for the next 6 missions up through 2016.
Yeah, which are already planned and budgeted for.
That's right.
Zecharia Sitchin's theories, of course, after he interpreted the Sumerian tablets and texts, that there's this extra planet in the solar system called Nibiru that has an elliptical orbit 3,600 years. What's your take on his theory, Tom?
Well, we've talked about that over the years. The celestial mechanics don't work. A single passage of an object like that through the planetary region drastically changes the orbital period. For example, when Comet Hale-Bopp was came in on an orbit with a period of 4,200 years, not all that different from 3,600 years, it went through the solar system, didn't come particularly close to anything, but the planets gave it enough tugs in this direction and that when it left, its period had dropped to 2,400 years from 4,200. So you can see how unstable such an orbit would be just from that. Repeated passages through the solar system result in either crashing into something or getting kicked out of the solar system. So it's really not a plausible orbit. If Sitchin's ideas hold any water, I think they'd have to be talking about planets of some other planetary system around some other star, and not ours, because the dynamics and the physical evidence just don't work out.
Let's go to the phones. West of the Rockies, Beverly Hills. Arbuckle, you're on Coast to Coast. Hey there, go ahead.
Yeah, hey, hi for picking up my phone here.
Sure.
Discussing this dislocation of the spin axis on Mars because of these asteroids. Am I right so far?
The explosion put a lot of weight on one side of the planet, which caused it the spin to become unstable and tip over on its side.
Yeah, that's what I'm led to believe. My question is, would this occur on Earth because of the, let's say, melting of the ice caps, for example? Would the spin axis of the Earth reverse itself to repolarize Earth because of the loss of mass on the at the Antarctic and the Arctic?
Poles, yeah. Good question.
No, there isn't enough mass there to change the axis of the Earth significantly. The Earth has so much, it's like a lot of Americans, overweight at the equator, shall we say. There's so much extra mass at the equator, and the poles are so flattened that the mass of the polar caps is not nearly enough to change that situation and cause any pole tipping for the Earth. Now, if the moon were to explode or a giant asteroid hit, that would be a different story. But these the global warming ideas, for example, are not going to cause any kind of pole change.
Okay, next up, first-time caller Rick in California. You're on the line with us. Hey, Rick.
How you doing?
Good.
I just kind of jumped in here in the middle of the show, so I didn't really hear everything you said. But I know that we got a probe up there right now on Mars, and I remember picking up a magazine recently, and it said they were experiencing some kind of problem with that probe. Can you elaborate on that if you know anything about that?
Which one are you talking about specifically? Because to my knowledge, we've got 3 working now.
One, I thought there was only one probe on Mars right now.
No, we've got the rover, the Spirit, and now the Phoenix.
Oh, okay.
Which
we know is the more recent one?
Phoenix.
Okay, that's the one that.
How's it working, Tom? It's working okay, isn't it?
At first they had some problems getting it to. It scooped up a sample and then couldn't get it to go through the filter screen because the material was so clogged that it wouldn't go through the tiny screen, so they couldn't get a sample into the oven to do their chemical tests on it. But now they've gotten around that, and they've gotten a sample that they can get through the screen, and they are in the process of testing it. And there are some more results that are supposed to be announced tomorrow, so stay tuned for that.
Okay, next up, let's go to international line. We're going to Toronto, Canada. Hi there, you're on the air with us.
Yes, hi, Terry from Toronto here. I have 2 quick questions. I'm wondering if it's possible that the moons around Mars are there because they impacted Mars. They sort of bounced off and then became in orbit. And the second part is, I wonder if it's possible if our moon was like a giant comet with lots of water, and it impacted the Earth, and that's how we gained the atmosphere. And I'm wondering if it's possible that the moon is in orbit because of an impact with the Earth, that the moon actually hit the Earth and bounced off, and that's why it's there.
The short answer is no, that's not possible, and the reason is because any orbit that has as a point on it a contact with the Earth or with Mars, as the moon goes out and comes back again, it's going to come right back to the contact point and smack it again and decay. In order to get into a stable orbit, you have to get something way above the atmosphere and then give it a horizontal thrust so that it can stay at that height.
Tom, do you go as far as Richard's theories on just how sophisticated life was on Mars? Of course, he believes that there was intelligent life there. How about you?
Well, I don't have to go by my personal opinions, which were mostly negative, as they were for most professionals, about that possibility. But we do have a lot of images from the Mars Global Surveyor spacecraft, and now coming in from Mars Reconnaissance Orbiter. And some of those images are pretty tough to explain without invoking advanced life, such as shrubs and trees, things that are changing with the seasons, and some of the anomalies, such as the 5 or 6 major faces that we see on Mars, and pictographs like we see in the plains of Peru and so on. It's really tough to explain those by natural processes. They are much too detailed to be the products of faces in clouds and faces in terrain.
Amy in Dallas, it's your turn. Hey, Amy, go ahead.
Hey, how are you?
We're great, thanks.
I was wanting to ask your guest if he believes in time itself as opposed to just being a human invention, and I would like to get his opinion on that.
Well, that's a very good question. There are a lot of theories about time, but the one that seems to be coming to the surface, so to speak, because it seems to make the most sense, is that time, the concept of time is indeed a human invention to measure change. Change is the fundamental thing, and that's going on all the time, all over. And all we do is find processes such as the ticking of clocks, whether they be mechanical clocks or atomic clocks, or just the dropping of sand in an hourglass, anything kind of change that is repetitious so that we can measure intervals of time, and then we attach numbers to them, and that's what we call time. So the answer is a bit of both. change is something that happens in the universe, and we measure it by something we call time.
Okay, good. Thank you. Next up, east of the Rockies, Russ in Ontario, Canada. Hey, Russ.
Good morning, George and Tom and our earthly and galactic neighbors.
You are welcome.
I wanted to address a very interesting bit of work put out by Jerome Corsi and Craig Smith, as offered up by Cornell, in terms of the composition of a moon around Saturn called Titan that is said to be comprised of seas of oil. Now, if you note some of the dialogue in the corporate world and the oil industry, oil is all about dinosaur and plant parts. Well, I asked the question, if that's the case, then was there so much life on this moon called Titan that we now have seas of oil, or do these two have it right in suggesting that the entire creation of oil is an abiotic process?
That's a tough one. It's heavily debated still, and I'm not an expert on the merits of the respective arguments, but out there at Titan, it's pretty darn cold, and the probe that the Cassini spacecraft sent down to the surface didn't have any kind of life detection instrument on board, but from orbit or from the spacecraft flying by the moon of Saturn, Titan, it was able to confirm that there are methane oceans there on the planet, and it's a good prospect for us to search for possible living organisms.
What projects are you working on now, Tom?
There's always a lot going on. The exploded planet hypothesis has a lot to say about the origin and evolution of the solar system. The Mars anomalies are always hot because there are constantly new images coming in. In the origin of the solar system, from the fission theory, we have a new article just coming out on that in a few weeks that ties up a lot of loose ends there. It makes it a pretty satisfying theory. The idea that the speed of light is no longer a universal speed limit, but gravity is an example of something that propagates much faster than light by quite a bit, and we've now found a way around the proof that nothing can go faster than light, which means the possibility of interstellar communication and even travel does exist in our future. The nature of origin and nature of gravity is a topic that we're working on all the time, and more has been learned about that. We now have a better understanding of gravity than at any time in the 20th century.
Let's go to our west of the Rockies. Kim in Idaho, you're on the air with us. Hi, Kim.
Hello. Good evening to you both.
Sure thing.
I would like the redundant question of global warming. Could I please have your opinion, Tom?
Well, it would be just an opinion because as an astronomer, I work on things in space and don't do research on things down here on the Earth. So I know no more than what I read in the journals and see in the debates. But my own personal opinion, since you asked for it, is that we are making major changes in the atmosphere of our home planet, and that's not a good idea for the long run. So we need to do something to preserve the natural composition of our atmosphere, lest we inadvertently do major and possibly irreversible harm.
Wild card line, let's go to you. Joe in Reno, you're up. Hi, Joe.
Hi, this is Joe from Reno. Your guest described how that planet X, if it were comet-sized and it came in along the plane of the solar system, would be diverted and its orbit would be a different number every time it came in. What if it were the size of a brown sun, something really massive, and came in from above and below so that it just hit the inner solar system, and it would seem to me that it wouldn't be changed much in its orbit very much, and still affect at least Earth, Venus, and so on.
Could you get an object that large to come in, Tom?
Sure, there's nothing that prevents a large object from coming in, but in fact, I wasn't talking about anything confined to the plane of the planets. Comet Hale-Bopp is nearly at right angles to that plane. It doesn't have to be anywhere near the plane of the planets to have the planets be able to tug on it once it gets to toward the inner part of the solar system. And as soon as it's crossed the orbit of Jupiter, in any direction, above or below included, then the orbit is going to be changed pretty drastically. And the same thing would be true of a large object. Remember, heavy and light bodies fall at the same rate, as Galileo first proved from the Tower of Pisa, and astronaut Scott showed on the moon when he dropped a hammer and an eagle feather, and showed that on an airless body like the moon, they fall at the same rate.
What do you think we're going to find if we send man to Mars, if we go to Cydonia, for example?
Oh, boy. I think we're going to get a lot of shocks, and possibly in the most interesting possibility of what we might find out, we may learn something about the origin of our own species. The possibility that instead of species, now I'm not speaking here against the idea of evolution. I've been to the Galapagos and other places, and I've seen evolution in action. But evolution within a species is one thing, and evolution across very different species is a different thing. And it's possible we might learn that life on this planet did not evolve naturally, but was seeded here from elsewhere, Mars being one of those possibilities. And that would be perhaps the most startling possibility. I always point out that whatever knowledge may be gained, school children in 50 years will look back and smile quaintly at how ignorant we were back here at the beginning of the 21st century.
Let's grab a quick one from Gary in Sherman, Texas. Go ahead, Gary. We've got about a minute for you.
Hi, guys. Hi, George.
Sure thing.
I've been a long-time listener, and I've got a question concerning you were talking about the nature of gravity, and I understand a little bit about some courses in physics or whatnot. Well, let's say I weigh like 200 pounds at the pole, standing directly at like the North Pole, right? When I weigh less at the equator,
you would. The equator has centrifugal force that would tend to throw you off the Earth. It's not strong enough to do that, but it lightens you. And you are also further from the center of the Earth at the equator because of the bulge at the equator. But on the other hand, there's more mass below you at the equator. The surface of the Earth tends to be pretty much an equilibrium surface, so that you're pretty much going to wind up the same wherever you are because of the counterbalancing of those two effects.
Tom, great information tonight. Thanks for coming on to talk about the research study of the ancient impact, maybe explaining Mars's mystery, bringing some alternative views to the table as well. That's Dr. Tom Van Flandern. Thank you to Richard C. Hoagland for getting Tom for us, and we'll be back in a moment.